Hello and welcome to another video on Pari GP. So today we will talk about some vectors, lists, and matrices and how they work in this program. Now, one thing that you can do in Pari GP is you can create your own list with numbers, a mixture of numbers, and also you can create lists with mixtures of other kinds of types. So let's start, for example, by doing something like this. So we can enter the list by hand. So let's say a list is always going to be with square bracket. And let's say we want the list of 2, 3, and 4. So we close the bracket there. And that's going to give me the list of those 3 whole numbers. Now, that a list doesn't necessarily have to be all of them of the same type. So you can mix types here in Pari GP. I'm just going to give another letter because I want to use these results a little bit later. So I'm going to open and close bracket here, square bracket. And let's say you want something like 1.4. So that is a float. And you can also use like a whole number there, 6, and maybe a fraction, 2/3, and maybe just the number pi. And Pari GP will still accept that as a list. So not all of them have to be of the same type. Now, if you want to see a little bit less decimals there, you can decrease the number of decimals as well. Now, you can also make list of list. So for example, I can say, let's use the lowercase z equals. I can make the list of, for example, the list of x, which is already a list, the list of y, and let's say, for example, 4/5. So that will make me a list of the first 2 is going to be sublist and then the number 5, and that is okay. So Pari GP will accept that as a list. Now, those are row vectors, or you can call them also list. If you want to use a column vector, you use the tilde that is in your keyboard. I'm going to show you where that is located in the screen. So if you're going to use like a column vector, let's call that W, let's say W. So you're going to start exactly the same as before. So you're going to start open the list, let's say something like 4, 6, and 9, and then close it. And to indicate that that is a column, you're going to use the tilde, which is in the upper left corner of your keyboard. Is usually there. So let me use that as a tilde. So that will indicate that that is a column. Now, if you remember from linear algebra, if you can use multiplication of a row times a column, and that will make sense. So if you look at the x is a row and W is a column, so I can use the multiplication. And multiplication here of matrices is indicated with the asterisk. So it's x times W, so I'm multiplying the row x times the column W because they have the same size. Then I should be able to get an answer from here. So that's going to be 62. Now you can also call elements of the list. So let's recall again what x is. So x is that list. So to call elements of a list or a row vector, you say x, open and close a square bracket, and is 1. So 1 here is going to give me the first element. So you start labeling elements of the list, not from 0, but from 1. So 1, 2, 3, and 4. The first element of that list, of course, will be 2. The second element, x2, will be 3. And the third element, of course, will be 4. So that also, yes, that's how you call elements of the list. Let me clear the screen here. Now you can also create matrices with rows and columns. So let's call it, for example, M, our matrix. So M will be equal, again, the same idea, open and close square bracket. And you're gonna start entering the elements of your matrix by the row. So the first is gonna be the first row, and it's gonna be like a list, 4, 3, and let's say 1. To indicate that you're gonna use another row, you use the same colon, and then you just enter like that. So for example, 2, 1, and let's say -1. And let me add another row. So it's going to be the third row. Again, another row is indicated by semicolon. And let's say we have 4, 3, and 0. So that will give me a matrix of 3 rows and 3 columns, as you can see right there. Now, you can also call elements of a matrix by the position where they are. So for example, if I want to know the element of the matrix, so I'm open and close brackets. So let's say I want the element in the second row, so that's indicated by 2, comma, the first column. So let's see what that gives us. That gives us 2. So that indicates that the second row is this one here, and the first column will indicate this number 2 here. Let's say another one. So let's say, for example, the element in the third row and the second column. So that will give me 3. So let's double check. So this is the third row, and the second column will just give me this element 3. So that's how you call elements of a matrix. Now, when you do this, make sure that your matrix is big enough to give you that element. So you can, in this matrix, you cannot, for example, say m or 1, so there is no fourth row. So make sure that you double check that when you call this code. Now, you can also call complete rows or columns of a matrix. So if you want, for example, of the matrix M, if you want the first row, you will indicate that by saying M, open and close the bracket, and then 1, comma, and don't type anything else. So that will give you the first row of that matrix, which is 4, 3, 1. And you can do that exactly the same with another row. So for example, the second row of that matrix is 2, 1, and -1. In a similar way, you can also call columns, and the code is basically the same. So you just leave the first component without anything, and then comma 1, that will give me the first column of that matrix, which is 4, 2, 1, and that is this column right here, the 4, the 2, and the 1. So you see 4 here. You see that tilde at the end? That's to indicate that it's a column or a column vector. And you can do that with other columns. For example, I can call in the third column of that matrix, and that will give me 1, -1, and 0, which is this here, 1, -1, and 0. And notice again the tilde at the end to indicate that that is a column. All right, so that's how you enter manually and call elements manually from a vector or a matrix here. So let me clear the screen again. Now, of course, it's going to be kind of tedious if you have to enter everything by hand when you create a list of a matrix. So you can also do things mathematically. You can also create matrices using generic rules. So for example, let's say you want to create a matrix of zeros. If you want to do something like that, you can say just matrix. And this is going to be the code that you're going to use to generate matrices according to some rules. So let's say I want a matrix that has 3 rows and 4 columns. If I just say something like that, that will create a matrix filled out with zeros, 3 rows and 4 columns, as you can see there. Now you can also put formulas here. So create a matrix using some generic rules, and you're gonna use the same thing. So you say, for example, let me correct that, matrix, and let's say I want a 4 by 4 matrix, and the rule here is gonna be in the ij column. I'm gonna put some specific number depending on where the position is. Now, if you wanna create a matrix with a generic rule, you will have to indicate a variable for the row, which I'm gonna put here as an I, and variable for the column, which I'm gonna be calling J here. You can call it X and Y if you prefer. And in the last part, I'm gonna put the formula I want for that. Let's say for the I column, for the I row and the J column, I wanna fill out that entry of the matrix, for example, with the formula I plus J. That will give me a 4 by 4 matrix using that formula. I'm gonna put some description here on the right hand side so you can see how that matrix is filled out. So that will be the matrix here. If you can see, this is exactly what it is supposed to happen. Let's look at this element 8 here. So this is the element in the 4 row, 4 column. So it's gonna be the element 4 plus 4, that will be 8. You can use things that are a little bit more complicated. Let's say, for example, I want also a 4x4 matrix, an I and a J to indicate the variables. And let's look at this formula here. So for example, 1 divided by this number, I plus J minus 1. Now, if you take in linear algebra, you might remember this matrix. This is called the Hilbert matrix. It's filled out with a particular way, which is this one. So usually just some fractions there. Now, any formula that you can imagine that has two variables, I and J, or X and Y, you can do that with the matrix. So you can create things like that. Let's say you can also create things with a random matrix. So let's say you want to make some kind of experiment with some algorithm and you want to create some matrix at random. You can do that as well. Let me clear the screen again. So we can say something like matrix, and let's just say in this case I want to have 5 rows and 5 columns, the I and the J, so those are the variables. And if you want random numbers, you can use the function random we talked about before. A random number here, if I put inside the parentheses a whole number, that's going to give me a random number between 0 and that number. And if I put a interval, it's going to give me whole numbers within that interval. So let's say I want random numbers between -3 and 3. That's going to give me a matrix of order 5 by 5 with random integers between -3 and 3. So let's see that. That's going to be the matrix that we get in this case. Now, you might wonder, well, how about the identity matrix? Do you have to enter that by hand? No. There is a way to do this in Pari GP. So if there is a matrix, in this case, the identity matrix is mat ID, and that's going to give me the identity matrix of a particular order. The identity matrix is always a square matrix. So for example, if I want the identity matrix with order 4, so 4 rows and 4 columns, that's going to give me the identity matrix of that particular size. So you can do something like that. You can put a whole number here in that, and it'll give you the size, the identity matrix of that size. You can also look at matrices that are diagonal. Let me clear the screen again. So for the diagonal matrix, those are the ones that have numbers in the diagonal and the rest are zeros. So you can create a diagonal matrix like that. So it's going to be mat diagonal. And mat diagonal, it expects a row vector. That row vector will be the one that is going to be positioned in your diagonal. For example, I want a matrix whose diagonal is, say, for example, 4, 6, and 3. So that's going to create a diagonal matrix with the entries 4, 6, and 3 in the diagonal, as you can see right here. 4, 6, and 3 here. So that's going to give it the diagonal matrix. Now, recall what I said before, the Hilbert matrix. That is also a way to create the Hilbert matrix, easier way than using matrix code, and it's called mat Hilbert. And the mat Hilbert is just generically gonna give you the Hilbert matrix of any size. So let's say of order 5. So it's a 5 by 5 matrix where the entry and the I and J position is 1 over 1 plus J minus 1. And that's gonna give you this automatically here. You can also do things like, for example, the Pascal triangle, and it's going to give you that in a matrix form. And the code for that is mat Pascal. So mat Pascal is going to give you the sort of the Pascal triangle, if you recall something, if you have seen that before, but it's going to be in the lower triangular part of that. So let's say I want the Pascal triangle. Let's say I had the first 6 rows here. And that will be the Pascal triangle here. The Pascal triangle is actually here in the lower triangular part of that matrix. So those are some of the things that you can do. And there's tons of things, tons of algorithms that are already implemented in PariGP. Now, how do you know that? How do you know which ones are already implemented? I'm going to clear the screen again. And we have seen this before. If you type the question mark, it's going to bring up all the topics that you can see here in PariGP. And if you look at here at number 7, so this is number 7 right here, that's the one you want if you want to create vector matrices and do some linear algebra with things. So let's just check a little bit what it says. This is number 7. And there is a lot of functions that you can use here. So the ones that I'm using here, actually, I took them from this list. And you can experiment and check what function does whatever you want to do. So make sure that you check this list first before implementing yourself a function on PariGP. Maybe it's already implemented here. Okay, let me clear the screen again. So let's look at some operation on matrices. So the operation on matrices is they wanna work as you will expect. Addition, subtraction, and multiplication work as you will expect they will work. So let me create a couple of matrices. So it's gonna create a matrix N, and I'm gonna create it with the matrix way to do it, so I don't have to type row by row. So let's say I want to create a 3 by 3 matrix, and the I column and the I row and the J column, I'm just going to put a random number. Let's say between -2 and 2. You can put any numbers you want here. This is just for the example. -2 and 2. Let me see if I did this. Okay, so I'm going to close this one. So that's going to give me the matrix N. So 3 by 3. I'm going to do another matrix here, so which I'm going to call M. So it's going to give me another matrix because I'm using random. You can add matrices. Of course, make sure that they have the same size, otherwise it's not defined. So you can say N plus M, and it works with the usual symbol for addition, just plus. So it's going to add the matrices. Subtraction is exactly the same thing. So this is with minus. So it's going to give me the subtraction of the two matrices. And you can also do multiplication of matrices. In this case, I have a 3 by 3 matrix. All of both N and M are 3 by 3. So it's okay if I just multiply the matrix. It's going to be N times M. And it's going to give me the result of that multiplication. Now, what else can you do? You can also do transpose of matrices. So let me clear the screen again here. So let's recall what N is. So N is that. To do the transpose is N tilde. So the N tilde is going to transpose that matrix. And as you can see here, every row became a column. So the first row here, 0, 1, 2, became this column 0, 1, and 2. So that will be the transpose. Now, the last thing I'm going to show you is the inverse, so the inverse of a matrix. Now, unfortunately, in PariGP, there is not a straight way to find the inverse of a matrix unless you want an inverse modulo some number. So if your matrix is composed of all whole numbers, you can take the inverse modulo 5 or modulo 7, for example. But for regular linear algebra in the real and the complex numbers, as far as I look through it, I don't see any algorithm. If someone knows, please put that in the comment of this video, but I couldn't find it. So in this case, what I'm going to do is I'm going to give you a little bit of code that's going to compute the inverse of a matrix. So in here, I'm just going to clear the screen, and I'm going to write a function that's going to compute the inverse of a matrix using the adjoint. Now for this, you'll have to know a little bit of linear algebra, or you just copy the code that I'm going to put here. So I'm going to put the code in the video description, so for you to check out. And because I type so slowly, I'm going to actually fast forward to the typing of this video. All right, so after typing all that code, so let me explain what the code is doing. So basically what I'm doing here is I'm creating a function that I'm gonna call mat inverse, so for the inverse of a matrix. And whenever you create a function, you always put an open curly braces and a close curly braces here. Now, the first part of the code is I'm checking the size of the matrix. This is actually a square matrix. So this mat size of A, what it's doing is giving me the number of rows and columns of that matrix. So this one here is giving me the number of rows, and mat size of 2 is giving me the number of columns. So what I'm saying here is this: if the number of rows is not equal to the number of columns, or that's the double pipe symbol here, or the determinant of the matrix is equal to 0, in that case, as you know from linear algebra, the matrix will not have an inverse. Now, if the matrix is not a square, it might have a left or right inverse, but we are interested in just the regular inverse. Now, if this is not true, so if the matrix is a square and the determinant is not 0, that's when the matrix will have an inverse. And in that case, we're gonna return this formula right here that is a formula for the inverse, which is 1 over the determinant of the matrix times the adjoint of the matrix A. That's one way to compute the inverse of a matrix. I'm gonna put something here in the video description here, so for you to check. So that's gonna give us a way to find the inverse of a matrix with real or complex entities. So let's for example, let's actually check our matrix N that we already have. So will this matrix N have an inverse? But let's check. So let's say mat inverse of the matrix N. So it does have an inverse, and that's the inverse. Now, how do you check that actually that is the inverse? So multiply by the matrix N. So we can say N times the mat inverse of the matrix N. And if the computations are correct, I should get the identity matrix, and I do. And it also works the other way around. Now, I'm going to stop the video here because there's a ton more functions that I can show you. About linear algebra is about giving you kind of an introduction to vectors, lists, and matrices. Now, in the next video, I'm going to show you a little bit more about lists and how you can create them. So there's an interesting topic for the next part. And that's all I have to say for today. Thank you for watching. Take care and good luck.